Hello guys, in this video I'll be solving an algorithms question with the title to sum. Let's dive right in. The question states, given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution and you may not use the same element twice. You can return the answer in any order. So I'll be going ahead to implement two different solutions to this question. The first will be a brute force approach, where I won't be so particular about how long it takes for the algorithm to run. In the second implementation, I'll go ahead to improve on how long it takes for the algorithm to run. Let's go ahead with the first implementation. So let's assume we have an array of numbers 2, 7, 5, 8, and 6, which I'll call nums according to the question. And we have a target 11. What I'll do is I'll go through every element in the array. For the current element under iteration, I'll call that the current number. Then I'll look for another number in the remaining elements of the array, such that when I add that number to current number, I'll get the target. So for the current number under iteration, I'll denote that with a caret. Now, starting from the first element in the array, which is 2, I'll check in the remaining elements in the array if a number exists such that when I add to 2, I'll get the target. So starting from 2, I'll check the next element in the array, which is 7. 2 plus 7 is 9, which is not equal to 11. So I'll go to the next element in the array, which is 5. 2 plus 5 is 7, which is not equal to 11. So I'll go to the next element in the array, which is 8. 2 plus 8 is 10, which is not equal to 11. So I'll go to the last element in the array, which is 6. 2 plus 6 is 8, which is not equal to 11. So I'm done with 2, and I couldn't find a number I'll add to 2 that will give me 11. So I'll go to the next element in the array, which is 7. So I'll put the caret on 7. I'll check. 7 plus 5 is 12, which is not equal to 11. I'll go to the next number, which is 8. 7 plus 8 is 15, which is not equal to 11. I'll go to the last element in the array, which is 6. 7 plus 6 is 13, which is not equal to 11. Now I'll go to the next element in the array, which is 5. So I'll put the caret on 5. Now 5 plus 8 is 13, which is not equal to 11. I'll go to the next number, 6. 5 plus 6 is 11, which is the target we are looking for. So the two numbers that add up to the target are 5 and 6. But according to the question, we're told to return the indices of the numbers and not the numbers themselves. And in JavaScript, arrays are zero index based. So what that means is the first element in the array will have index 0. The next element in the array will have index 1. The next element index 2. The next element index 3. And the final element will have index 4. So since 5 and 6 are the numbers we are looking for, we'll return index 2 and index 4 as our results. Now let's assume after going through every element in the array, we couldn't find two numbers that add up to the target. Then we'll go ahead to return an empty array. So this is the visual explanation of the algorithm. Let's go ahead to implement this in code. The first thing I'll do is to iterate over every element in the array. I'll call the elements at index I current number. The next thing I'll do is to iterate over every other element in the array. I'll call the element at index j other number. Next, I'll go ahead to check if current number plus other number adds up to the target. If current number plus other number adds up to the target, I'll return the indices of both number in an array. The index of the current number is I, while the index of other number is j. But after going through every element in the array, I couldn't find two numbers that add up to target. Then I'll go ahead to return an empty array. This is the implementation of the algorithm. Let me go ahead to run the code. This is successful. Let me submit the code. The submission is successful. The next thing I want to talk about is the time and space complexity of this algorithm. The time complexity of this algorithm is big O of n squared. And the time complexity is big O of n squared because for each element in the array, I'm going through every other element in the array to search for two numbers such that when I add them together, I get the target. The space complexity for this algorithm is big O of 1, which is constant space. And it is constant space because the only extra space I'm using is an array of the indices whose numbers add up to the target. So irrespective of the size of your inputs, the input array, you would always return an array of two indices if two numbers that add up to the target exist. But in a situation whereby you couldn't get two numbers that add up to the target, you return an empty array. So that's it for the brute force implementation of this algorithm. I'll go ahead to implement the optimized version of the algorithm. In this implementation, I'll make use of a key value data structure. And in JavaScript, an object is an implementation of the key value data structure. Each entry in the object would have a number in the array as the key, while the value of the entry would be the index of that number in the array. So starting from the first element in the array, which is 2. 2 plus 9 gives me 11. So I'll check in the object if an entry with key 9 exists. But an entry with key 9 does not exist in the object. So I'll go ahead to add an entry with key 2, which is the number in the array, and the index of 2 is 0. Now I'll go to the next element in the array, which is 7. 7 plus 4 gives me 11. So I'll check in the object if an entry with key 4 exists, but an entry with key 4 does not exist in the object. So I'll go ahead to add an entry with key 7, and the index of 7 is 1. So I'll check the next element in the array, which is 5. I'll put my caret on 5. Now 5 plus 6 would give me 11. I'll check in the object if an entry with key 6 exists, but an entry with key 6 does not exist in the object. So I'll add an entry with key 5, and this maps to the index of 5, which is 2. Now I'll go to the next element in the array, which is 8. I'll put the caret on 8. 8 plus 3 gives me 11. Now go ahead to check the object if an entry with key 3 exists, but an entry with key 3 does not exist in the object. So I'll add 8, and this maps to the index of 8, which is 3. Now the last element in the array is 6. I'll put my caret on 6. 6 plus 5 gives me 11. So I'll check in the object if an entry with key 5 exists, and an entry with key 5 exists, which is this particular entry here. So what I'll do is I'll return the indices of 5 and 6. The index of 5 is 2, and the index of 6 is 4. And in a situation whereby I had gone through every element in the array and I couldn't find two numbers that add up to the target sum, I'll go ahead to return an empty array. So this is the visual explanation of this algorithm. Let's go ahead to implement this in code. The first thing I'll do is to declare a variable that holds the object. I'll call the object CNumbers. Then I'll iterate over every element in the array. The element at index I, I'll call that current number. Then I'll get the other number that I'll add to current number to get the target. So I'll call that other number. So to arrive at other number, I'll subtract current number from target. I'll go ahead to check if other number exists in CNumbers. If this is true, I'll get the index of other number. Then I'll go ahead to return the indices of both other number and current number. So the index of current number is I. This is supposed to be CNumbers, not sin. The index of current number is I, while the index of other number is other number index. Now, in a scenario where other number does not exist in CNumbers, then I'll add current number to CNumbers. That means I'll add current number to the object. The index of current number is I. Now, after going through every element in the array, and I could not find two numbers that add up to the target, and I'll go ahead to return an empty array. Okay, let me run this algorithm. Okay, these are passed. Let me go ahead to submit. This is successful. The next thing I want to talk about is the time and space complexity of this algorithm. For this implementation, considering the fact that I went through every element in the array just once, while in search of the other number, the time complexity is big of n. For the space complexity, it's big of n also. And the space complexity is big of n because I needed to use an extra space to keep track of the numbers that I've seen so far. And in a worst case scenario where I can't find two numbers that add up to the target sum, I would have gone ahead to add every element in the array into the object. So that's it for this implementation. In the first implementation, we had a time complexity of big of n squared, which was not too good, but a space complexity of big of 1. In the second implementation, we improved on the time. We had a time complexity of big of n, but we had to compromise on space. The space complexity was big O of N also. So that's it for this video. Thank you for watching. If you like this video, give it a thumbs up. If you like to see more videos like this, subscribe to my channel. And if you like to get notified whenever I come up with a new video, hit the notification bell icon. I'll see you guys in the next one.